Oh, that's not too bad. It's not too good either, but weird. Who are you? Oh, there you are. Okay. Oh, you need
Can I
one?
have the Thursday paper, please?
The who now?
The Thursday paper?
This one?
Yeah.
Okay. You need it too?
Yeah, that's good.
Okay.
Thank you.
So on Thursday, we went over completing the square. Very first thing we're going to do today is prove quadratic formula, which just sounds exciting. No? Okay. Morning. All right. But the very, very first thing we want to do, remind me, who had the question I said I was going to get back to? What was it again? Sorry. Oh, here we go. Okay. All right. Can anybody give me two numbers that multiply to be 8? Multiply to be 8. That's insane. So if I have, oh geez. Come here. Somebody's got to work. I have a number times a number equals 8. It could be 4 and 2. What else could it be?
-2 and -4.
-2 and -4, kick ass. What else could it be? -1, -8, or 1 and 8. What else could it be?
16 and
Yes, 16 and 1/2. What else could it be?
32 and
32 and 1/4. What else could it be? 80 and 1/10. What else could it be? 80 and 1/100.
It could be 2 to the third power. Oh wait, 2 numbers, never mind.
Yeah. Do you understand? Couldn't I just keep going with 80 and 1/10, 800 and 100th? Couldn't I just keep going with that forever? And aren't there infinite other things also? I really need you, just that by itself. Let it be disconnected from everything. It's just, if I say two numbers multiplied by 8, bless you. Do you know anything about either number? No. They could be anything, as long as together they make 8. Once you pick one, you can always pick the other one. Unless one of them is 0. Yes? Now, what if I have two numbers that multiply to be 0? Jeff, what is going on? What has to be true? What do we know must be true? One of them has to be 0. That's the only way for this to work, correct? You guys with me? What does that have to do with anything, Jeff? Well, I don't know. Oh yeah, that's right. This. So if I have, for example, you can do it, man. Can you? Let's see. Sure. I could factor this. I have two numbers multiplied to be -3. -3 is a little bit worse than 8, but do you all agree I could do the same thing? I could get an infinite number of possibilities. That doesn't mean there's an infinite number of answers. I don't know if you guys, does everybody understand that this has got way too many possibilities?
Yeah.
Do you guys get that? Give me two numbers that multiply to be -3. I'll start. 1 and -3. -1 and 3. Give me another one.
-3 and 1.
I already said that.
Oh, sorry.
That's okay.
-6 and 1/2.
-6 and 1/2. Yes? -90 and 1/30. Yes? Do you guys just playing with the numbers? Do you see what I'm saying? So there are too many possibilities to check, because you have to check all of those. Because not only do the two numbers have to multiply to be -3, they also have to be 1 is 4 plus the other one. So they have two conditions and you have to check both of them, and I don't want to do that for an infinite number of things. Let me stop for a minute. If instead, from the beginning, screw this shit, what if instead I had added 3 over and to make this 0 now? How does this factor? Both positive, so it comes out plus in the middle? Or it comes out 4 in the middle, really. You guys see that? Do you see how I have two numbers multiplied to be 0 now? Do you see that's a number? Yes. Does everybody agree that's a number? You with me? If you say x is 7, then this is the number 10. So this is a number. This is a number. What happens when two numbers multiply to 0? Either the first one is 0 or second one is 0. So I go from an infinite number of things to check to two definite answers. So which one would you rather do?
Infinite.
Okay, if you want to do the infinite, go for it. Just, you're going to kill a lot of trees, man. You'll be in the corner. I'm still working on a problem. You stop for a minute. You guys, does that make sense? What are the two answers then?
-3.
Yeah, what makes this 0?
-3.
-3. And what makes this 0?
-1.
-1. Okay. Maybe? No? No?
Can they both be 0?
Sorry?
Can they both be 0?
I mean, not really. Because if this one is if x is 2, this is 3, and this is 6. If x is 2, this is 3, this is 5. They have to be 2 apart. They can't be the same thing. Do you see that? So they can't both be 0. But one of them has to be 0. That's why there's two solutions. There's two different ways to make one of them 0. Sorry?
-3.
What about -3? Yeah, -3. That would make this 0, which makes the whole thing 0. Yes. Okay. Is that better? I'm certain a lot of you guys know to set it equal to 0. So when do I do that? When I see a power on my x that's different from 1. If that stupid thing wasn't there, if that wasn't there, how would you solve that? 4x plus 3 equals 0. How would you solve 4x plus 3 equals 0? Huh? Subtract 3, divide by 4. Right? It's if my x terms have different powers, so I can't combine them. How do I solve equations? I try to get all my on one side and all my well, how do I solve equations? I get all my x's on one side, all of my what's that? I know you all know this. You know how to solve equations. To solve an equation, you get all my x's on one side, all my numbers on the other side, correct? If I can't combine my x terms, I need another way to do it. Can you combine your x terms?
No.
They're not like terms. So factoring gives us another way to do this. Okay, maybe. So don't factor too early, because this doesn't lead you anywhere good. You have to get it equal to 0 and then factor. Okay. And maybe. Anything else? Anything from homework stuff? Or we could do another example like this. Yes?
2.5 35.
35? Oh, yeah. Oh, yeah. Okay. We haven't officially talked about the the quadratic formula. So let's do that if there's no other questions. We're going to go ahead and prove the quadratic formula, and then I'll tell you what this means, discriminant. Okay. Any other questions before I do that? Yes?
Where exactly are we supposed to be on?
I would say if you're in 2-4, doing some problems from 2-4, you're in a decent place. You really should be about to get into 2-5 if you haven't gotten there already. If you're in 2-6, cheers. You're amazing. Right? And for the rest of you who aren't there, they're overachievers. Let them do what they want. Yes? You with me? All right. Maybe? So nothing is late yet, correct? When's the first time something's late? After the test. Kick ass. So you always have some time, but dear God, do what you can to not give me everything at once. Please. To bring a wheelbarrow with me on test days. You guys with me? Oh, by the way, I was about to say I've given some back already. Here's some more. Marie, Alexandro, and Khadija. Donde? Khadija. So if you give me homework, I will give it back to you just like I just did. If I say, okay, you got full credit, even though you might have made a couple mistakes, you should still review it. If I say correct, that means you have to make corrections. You have half credit currently. And if I say redo, that means you have to redo it because you made too many mistakes or left too many blank. When are homework corrections due? When are homework corrections due? I should have worn my other shirt. It's in the syllabus.
Same as their test.
No?
Oh.
Homework corrections are due the day of the final exam. Do you understand? Do you understand? Basically, everything else is due the day of the next test. We haven't taken a quiz yet, but quiz corrections. We haven't taken more than one test yet, but test corrections, quiz corrections, new homework, they're always due the day of the test. Homework corrections due the day of the final. Okay, how we doing? Yes, sir.
Sorry, you just answered my question. Never mind.
Kick ass. Oh.
If you say ... okay, it's
You're
full
good.
credit, but I missed something.
It's kind of funny. The more dots I put, the closer you were to me making you make corrections.
Okay.
It's not even, I don't even do it like purposefully. I'm just like, okay. So definitely review when you have a few dots in front of you, okay.
Okay.
Okay. So everybody with me? Everybody with me? And everybody has found the homework, correct? And everybody knows what E30 means. Yes? Every third one, not every third odd. Okay. It's like I told you, week 5, I'll have somebody say something like, oh, we have homework due? I'm like, what the shit's going on? Okay, all right. So let's do this. Let's prove quadratic formula. How's that sound for Monday at 8 something? Before we do that, let's do a quick here. Everybody's got this sheet now, right? Does anybody still need this sheet? It's the one that's got all the stuff on the back. Has everybody got this sheet? Does anyone need this sheet? Oh, here. Sure. Okay, one side is just all the various ways to solve a quadratic, meaning you have a square on one of your variables, at least. How to solve those, and the other side is a deep dive into probably the weirdest way, which is completing the square. So,
Oh wait, I don't have that.
Oh.
I have a different one. Thank you.
you're welcome. So I'm going to do this here. Let's do both of these. What's the first step in completing the square?
Getting the 11 on those.
Good. Hello. So what's the first step after that? I love it. Make some room. Get the 11 the shit out the way. Yes.
Divide -6 in half.
Yes. Cut the middle line in half. And if you're like, why do we do that? Well, we went over that. We did the motivation. If I multiply stuff out, it's a pattern we noticed. So if I take the middle dude and cut him in half, what do I get?
-3
That's insane. And then I take that and I do what to it?
squared.
Square it. What do I get?
9.
What does this tell me to do?
Add 9.
Add it to both sides.
What does the eyes on the left side mean?
What is the what now? Oh, shit and a half.
Numerals.
This is step 1. This is step 2. Okay. I just default to Roman numeral kind of outline. You guys have taken English. You know when you make an outline, you have Roman numerals, yes? Okay. But you're right. We talked about the measure number, so you're right. Okay. Does everybody see how I added 9? And I have to add 9 to both sides. If I don't add 9 to both sides, I'm in as much trouble as Indiana Jones was. The big boulder's going to come because they didn't balance things correctly. Now, this is not very hard to factor. Yes? Two numbers that multiply by 9 add to be -6. But it's especially not hard to factor because that's always the answer. The first step always tells you how to factor the thing you get. So this is x minus 3 squared equals 20. Is that cool?
Yes.
So what has that done for me? That is the goal of completing the square, is to make that. Do we have a squared term up there now?
Yes.
And how did we get it? By going through the thing called completing the square. So that's why it makes sense. When I added 9, I completed what I needed to write something squared. What can I do now? Because where's my x? It's right there. What is it stuck inside of? Stupid square. So I can kill it though, yes? Okay. So I watched a lot of Game of Thrones. We'll only talk about up through about season 6, maybe. So a lot of my math is very, I even did this before I watched that. It's very violent, and I'm sorry. Things die. They'll be okay. They come back. Little zombie variables. So I want to kill that square, because that'll free my x piece up. Of course, if I do this, what do I have to do at the same time? Plus or minus. So this side, these kill each other. Does anyone know what can you do with that rad 20?
4, 5.
So just like when you get fractional answers, you have to check to see if it reduces. When you get radical number answers, you have to check to see if it simplifies. Yes? That's why I just call it reducing the radical. It really isn't that, but it kind of makes it the same level as reducing a fraction. So how can you break 20 up? So you can do a part and leave a part.
4 times 5.
I really want this to make sense. 20 is 4 times 5. The square root of 4 is
2.
and the square root of 5 is square root of 5.
Oh, yeah.
So this is square root of 4 times the square root of 5. So this is plus or minus 2 rad 5. I do the part I can. I leave the part I can't. Sounds like a life lesson. That's the serenity prayer, right? Sorry, except it includes turning people's ankles. Then I got one step left. Yes?
And 3 to
I have
6.
3. Now, real quick. I really want to point. Can you factor this? Are there numbers that multiply 11 add to be 6? Negatives?
Technically,
Not particularly. It's a perfect way to say it. There are numbers that do that. Are they nice numbers I want to work with? No. In fact, now we know what the numbers are. We know exactly what multiplies to be 11, adds to be 6. I really want you to realize these two numbers. Is everybody cool with there's two numbers here? Can somebody give me one of the numbers here? Why are there two numbers here? Why are there two numbers here? Plus or minus. So what's one of the numbers? 3 plus 2 rad 5. And what's the other number? 3 minus 2 rad 5. Those are the two numbers that multiply to be negative 11 and add to be negative 6. I really want you guys to realize that. When I can't factor it, what that really means is I can't factor it using whole numbers or integers. So do I want to if I can't get integers? No, I do not want to. Screw that shit. So I can see what the answer would have been now, and there ain't no way in hell I would have gotten that just by sitting there and thinking about it. Okay, maybe? Okay. The more you understand why we do things, the less you have to memorize it. I think I've said this to you before, but if I memorized all the math I'm able to do, I would be gibbering in the corner because I would forget everything else about how to operate in the world to make room. So I can do a lot of math. I can. Ooh, look at Jeff posting. Who gives a shit? It's my one skill show. I can do a lot of math, but I didn't memorize all of it. Oh my God, no way. So it's more, the more you understand why we do something, the less you memorize it and the more you do it because it makes sense. I don't have to remind myself, don't put my hand on the stove. It just makes sense not to put your hand on the hot stove. Okay. All right. Let me see. I'm going to go, let's see. I can't really go through this quickly. What's the first step in number 2? What's majorly kind of wrong with how 2 is presented to me?
You need more space.
I need more space, but more importantly,
There's a 9 in front.
There's a 9. Completing the square is hardwired on the first coefficient being a 1. It requires that. If it isn't, we just divide. What do we hate about that fact?
That 27 divided nicely by 5 doesn't.
You all excited about that?
No.
There's 2 things freaky about that. And I'm going to show you why we shouldn't care that much. Because what's the first step now? I've got room. My first number is a 1. Completing the square will work. What's my first step?
Divide 3 by half.
Divide 3 by 2. And then I take that and I square it. Now here's the thing that you guys have the most trouble with, and I don't blame you. When things start to look weirder, you lose touch with how it works. How it works cannot change. The process doesn't give a first shit that there's fractions floating around. We do the exact same thing we did just in the problem before. What do I add to both sides? It doesn't matter how much you hate the fact that you have to do that. I mean, I agree with you. I don't want to do that, but that's what I have to do. Whatever the shit I get on the second step is what I add. So this, and I have to do it to both sides to make it legal. And what does this tell me, thank the gods? How does this factor without doing any thinking?
X plus 3.
3 over 2.
Let me see if I can, that'd be amazing if I could suddenly write. Oh well, too bad for everybody. Especially helps the worse the numbers get. I didn't have to do any factoring. I just had to put 3 over 2 in there. That's how completing the square is hardwired. That's what it gives me. Thank you, completing the square. Now, 5 9s plus 9 fourths. That's the most that we have to do with fractions. That's the one step we actually have to do something with them. Do you guys agree there's a lot of fractions? Most of them we don't give a shit about. They're just sitting there. Let them sit there. This is the one thing we have to do. And I want to show you a neat shortcut. Would you agree that 9 and 4, neither one of them is prime? Are you guys cool with that? Right? 9 is 2 times 3, 4 is 2 times. Let me see if we get this. Are they relatively prime? 9 and 4, do they share any factors? No. So then, okay, I almost don't want to do this. I could do something that's sort of like cross multiply. What does he need then? What do I multiply him by?
4.
4. And what does he need? 9. Yes? And then they would be both 4 times 9. Are you with me? So couldn't I just do that 4 times 5, 9 times 9? And put that over 36. Okay, that might be a bit much. I'm going to let that stay there. If you want to think about it and do it, go for it. Let me just do it the straightforward way. Give him a 4. Give him a 9. So I get 20 plus 81 over 36. Is that cool? 4 times 5, 20. 9 times 9, 81. Add those together. All over the common denominator. I love you guys. Anytime we're doing something, I don't care how basic I make it sound. If you don't understand what I did, just ask. If you have the question, at least 8 other people have that same question. Yes?
I just want to know how you got 3 over 2.
Oh, so I could figure that out, multiply to this, add to be this, but this always tells me, the first step always tells me how this is going to factor.
Right, but it's because you usually the first step is dividing by 2, right? So how did you?
We did. What was the middle term?
The middle term was
3.
Okay.
And then we divided that by 2.
Oh, okay, gotcha. Okay, I see from the 27.
Don't
Okay.
make decimals. Decimals
Gotcha.
actually make things worse. And I know we go to decimals because we don't like fractions, but it's weird how fractions actually makes math easier. A lot of you guys don't believe me, but that's okay. What do I do now? Let go that there's a really gross fraction there. Who gives a shit? I have to do so little with it. Square root it. So it's not the numbers that tell me what to do. I want to kill that square, so I'm going to square root. Put plus or minus. I'll do this side. What's the square root of 101? I don't know. What's the square root of 36?
6.
And then what's the last step?
Subtract 3 over 2.
Subtract 3 halves. I want to get x by itself. There's a fraction with it. Do you understand that we don't care? Do we have to do much? I really want you to get this. This looks so mean. Look at that. That's gross. How much did we have to actually do with the fractions? This. That was it. This is the one thing we had to do was get like denominators. Students kind of give up though when they see, look at those fractions, I'll just go to the next one. You barely have to do anything with them. They're just sitting there. So the last step is get rid of the 3 halves. Subtract it over. And the beautiful thing is, I'm done. Okay, maybe? Maybe? Okay, maybe? Yes?
You were talking about prime numbers with 9 and 4.
Yes.
What if they are a prime?
Oh, then it's even better. Then they definitely are just missing each other. So the idea of relatively prime just means the two numbers don't share anything. So when I'm trying to get a like denominator, if they're relatively prime, they need each other. But if I'm trying to get an LCD for 1/8 and 1/2, the LCD is not 16, correct? Because 2 and 8 are not relatively prime. 8 has a 2 in it. Do you see what I'm saying?
Yeah.
Okay. How much do you have to actually understand what I just said? Not at all. But it's just a kind of a different way to formulate how to work with fractions, if you want to. It's not a way I'm saying you have to do it.
Could you rewrite the answer as x equals -9 plus or minus?
Oh, hell yeah. You can get an LCD and then put those together.
Uh-huh.
But the reason I'm not going to is because the top couldn't go with rad 101 anyway. But if you do it, tears for you.
Just so it looks like I did the quadratic.
Understood.
Yeah.
If you got an LCD, and I would just multiply this by 3, so then I get -9 plus rad 101 over 6. And that looks like something you would get, plus or minus, that looks like something you would get from quadratic formula.
Where did the times 3's come from?
If I want to get an LCD,
Okay.
I got to multiply by 3 to make it 6.
Okay.
And then I can put them together.
Mm.
And do you understand though, I circled this without that? You can stop there. I'm so cool with that. Now, if that was 11, then you should go further because then you can reduce it. But it isn't, so I don't care. Is that cool? But you're right, I like that. I like that that inclination. Make it look like what you would have gotten from quadratic formula. Okay. I love you guys. So we're about to do something that you're like, yes! So everybody just remain calm. You're doing great. We're going to prove the quadratic formula. Yeah. My life will be complete. Okay. Is anybody at all intrigued? At all, like a little bit. Especially because I'm not going to make you do it. You're just going to help me.
Are you going to take the Pythagorean theorem and solve for x? Or
No.
No, okay.
You ready? Quadratic formula's job is to solve this equation. No matter what A, B, and C are. Yes? If you remember quadratic formula, that's it. Don't you have to figure out A, B, and C and then plug them in? Isn't that how it works? Okay. So we're going to solve this. We're going to solve this by hand. What freaks you out the most about that?
There's 4 variables.
There's no numbers. Except the 2 is an exponent, but that's not really a number. It's just how many x's, yes? You guys with me?
Yeah.
But remind me, what did we just do on the problem we just did? The one that was 9x squared plus 27x was the first thing we had to do. When it was 9x squared, that problem we just did, what's the first thing we had to do?
Get rid of the number. on
Get rid of the 9. Because the first number is supposed to be a 1. So is this, what do we have to do here? I can do 2 things.
Divide everything by 8.
Divide everything by a. And the 0 is awesome because it just eats it. And then what do I want to do? I want to get somebody out the way. What do I want to do? I'm doing completing the square. Let go of the fact that not only are there letters, but there are now fractions with letters. What the shit are you doing to me, Jeff? Let go of that shit. Let go of it. What do I do?
Subtract C.
Yes, I want to make some room, right? Are you going to have to do this for your own? No. Am I going to give you a bunch of problems like this? No. This is a derivation. So whenever we do a derivation, I'm going to remind you, I'm not going to expect you to do this by yourself. We're deriving the quadratic formula now. And I'm not sure if anybody's ever seen this derivation before, but you all know quadratic formula. Is this true?
Yeah.
Even if you don't kind of remember it right now, could you guys start it off negative b plus or minus the square root of? Okay. So now you're gonna, pretty soon you're gonna start to see shit that looks familiar. And you're gonna own it more. You're gonna see it's not just math people going, yeah, let's put a over 2a. How's that sound? Yeah, let's do it. No, it's just what happens. So, yes.
What is AX, what's that formula at the top? What is that called? That has a name for it, right?
It's the standard form for quadratic.
Okay.
Yeah. It's also known as the standard form for a parabolic function because that's what it looks like when you graph it.
I gave it the wrong name. I called it the Pythagorean.
Oh, I see. That's what you thought of it. Okay. I wasn't sure how Pythagorean theorem was coming into things when you said that.
I
Okay.
just had the wrong name.
You're fine. There's a lot of names flying around. So I'm going to subtract C over A. I desperately want you to see, again, start to train your brain to be cool with the fact that there's freaky looking parts of this. Because the process is the same. What do I do to complete the square? You guys see the middle term, what do I do to him?
Divided by 2.
Yes, and here's how you do it when we're dealing with fractions. What's another way to divide something by 2? Multiply it by a half. Is that cool? So when something is already a fraction, I don't want to put fraction over 2. That's trippy. So I just multiply it by a half. So I take the first step, take half of b over a. There you go. And what's the second step? Take what I got and square it. Is anything starting to look semi-familiar here, sort of? You guys see some parts that sort of look familiar. Okay, we'll get there. So, again, the process doesn't give a shit what it is. What do I do with b squared over 4a squared? What do I do with that? Always, the second dude, what's it tell me? What do I do with him? Add it to both sides. Okay. I know this is uncomfortable. The nice thing is we're doing this together. I'm not going to quiz you on this process. You're not going to have to do this on your own. What I want you to do right now is say, oh, we're doing exactly the same shit we've done every single time. We try to take over the world. No. Cut the middle term in half, square it, add that to both sides. Now, would you want me to give you this problem just sitting by itself and say factor this? No. But why is that not a problem for us now? How do I factor this? How do I factor this? You can do it. X plus b over 2a, all of it squared. Yes? That's the power of completing the square. Whatever the shit this is how this factors. Okay. What do I do over here? This is the one place we actually have to work with the fractions.
You multiply it by...
I want to get LCD here, yes? Please don't freak out. Do you see which one is missing stuff?
Yeah.
Which one?
Left side.
The first dude, right? What is he missing?
4.
A 4 and another A. Then they would be the same, correct? So he's not missing shit. He's got an A. And this line is like, good for you. So I have to give this guy a 4 and another A. So I do that. and multiply the top by 4a, and then multiply the bottom by 4. Then I'll get b squared minus 4ac, interesting, all over 4a squared. Careful. You got a little ahead of yourself. We're not there yet. But do you see what's going to happen next? Those of you saying over 2a, I'm with you. That's what's in the quadratic formula. We're not there yet. What's the denominators? 4a squared. What do I do now?
Square root?
Square root. Kill that stupid square. Yes? If I take a square root, I also have to put
Plus or minus.
plus or minus. So over here I get, and over here I get plus or minus, what's the square root of b squared minus 4ac? I don't know. What's the square root of 4?
2.
And what's the square root of a squared? There's your 2a, yes? You knew it was coming, but don't just shove it in there. Let it come. It's got to. We know how it ends. And then what's the last step? Every step we've done so far, by the way, is exactly the same as that 9x squared plus 27x problem. It's all the same steps. Last step is subtract b over 2a. And don't they have a common denominator?
Yes.
So I'm going to go ahead and put them together. Because they already have a common denominator. There's your quadratic formula, yes? Okay. Some of my colleagues are always a little reticent to show that, but you don't have to do it. You just have to absorb facts, right? You're not going to have to rederive this. You can use the result now, because we just proved it's true. If I have an equation that looks like this, I can get what x is by plugging b, a, and c in. That's the power of that. So how many equations did we actually just solve? An infinite number, because what could a, b, and c be?
Any number.
An infinite number of things, yeah. As long as a is not 0, yes.
So is the reason why the power of 2 on the b squared stays because the square root stays?
Yeah, I can't do the square root of a part of a problem.
Okay,
Yeah.
gotcha. But if it was like an actual number, you can.
If this was b squared times 4ac,
Okay.
then the square root of b squared is b, I could put that on the outside, because roots are based on multiplication. They're based on exponents, which are based on multiplication. They are not based on subtraction, that's why they don't distribute.
Gotcha.
Okay, I like it. Okay, maybe. Maybe? Yes?
When multiplying the fractions, the reason you didn't multiply both sides is because we're missing one side, not two.
Oh, yeah, totally. To make the bottoms the same, I only had to change this first guy. Then they're both the same. So people get confused because you get so used to in algebra, if you do something on one side, you have to do the other side. That's exactly what we did. I did something to the bottom side, so I have to also do it to the top side. I didn't do a damn thing to this side of the equation. I did something up and down here. Can I cancel what I did and get back to what it was? Yes, so it's legal. Okay, I like it. Yes?
Why can't a be 0?
Just look at the result. 2 reasons why.
Can't divide by
One is immediate.
Can't
If
divide
a is
by
0, it's divided by 0.
Right. Okay.
Secondly, if a is 0, then I don't really have a quadratic. I could just subtract c divided by b.
Yeah.
Okay. That's why the result is not invalid because it can't handle a equals 0. If a equals 0, I don't need it. I could just subtract c divided by b and be done with it, yes? Okay. Maybe. These are all really good questions. You all have used quadratic formula before, is this true?
Yes.
Okay. Do you really want to do an example or are we good? If you just figure out what a, b, and c are, you're golden, yes? Okay, no one's speaking up,
I
okay?
feel like there's some people that don't remember the quadratic equation.
Alright, let's see. Let's do one we already did. That might be too gross. Yeah, let's do this. What is A?
One.
Here. 1. What is B?
-6.
What is C?
-1.
Good. So then the answer is negative B plus or minus the square root of b squared minus 4ac r2a. Okay. Negative b plus or minus whatever. Be really careful. People will do this and get negative 36, which is really neat. And then that throws everything to shit. Yes? So just don't do that. Negative 6 is 6. Negative 6 squared is 36. Negative 4 times negative 11 is plus 44. What is 36 plus 44? 80. 80 is, get out of there, Jeff. 16 times 5. I'm going a little fast, I'm sorry. Right? 80 is 16 times 5. I have to do that to break it up so I can do the square root of what I can do. This is 6 plus or minus 4. Square root of 16 is 4. Square root of 5 I don't know. And then if I divide both of these by 2, is that what we got before? Is that what we got before? Yes. And to be honest, I would argue that the completing the square we did was actually a little quicker than this. So this is supposed to be a shortcut. Most of the time it's a little quicker, sometimes it's a little slower. Yes?
Where did the 16.5 come from?
16 times 5, sorry.
Oh, 16 times, that makes
Yes.
so much more sense.
Yes, it totally does. Otherwise I'm just up here hallucinating like I'm a GPT.
I was like, how did we get decimals in here?
Yeah, I don't blame you. Yes?
So no matter what, if you do complete the square quadratic formula, you're bound to get the same answer.
You have to. I really want you to realize, how did we make quadratic formula? How did we create it?
By completing the square.
We use completed square first and then plug numbers in. If I use completed the square and I use quadratic, I have to get the same answer because they're the same thing. I'm just doing the math in different order. So of course I end up with the same thing. Okay, maybe. Quadratic formula is one of those things that everybody remembers the name and they sort of remember the formula. But I don't know if everybody's seen where this shit it came from. Right? If you never see where it came from, part of your brain just says, oh, they make this shit up. Okay. Yeah, maybe. Alright. Oh yeah, okay. Now we're getting into some exciting stuff. So let me ask you this. How would you solve this equation? Yes. You definitely don't FOIL. Although if you did FOIL and added 16, you could then factor, it would still work. But why? Because right now I can just square root, put a plus or minus, these kill each other. What is the square root of negative 16?
Plus or minus 4i.
4i, I like it. We're beyond saying it doesn't exist, because we know it does. And now what are my last two steps?
Add 5 to both sides.
Add 5, divide by 2, right? And I always get weird shit here. Can I somehow get a 9 out of doing this? Because these two are not like terms. So I just put 5 here, and then I divide by 2. And you can stop here, or you could break it up and divide the 4 by 2. Either way, either way. Maybe. And how would you solve, how would you solve this? I'm sorry, I went back to my Roman numerals, but nobody's yelling at me, so. You can do it, Jeff. Would you got a quadratic formula for that? Shit, no, don't do quadratic formula. That's a long-ass way to do this problem. What do you always try first if you have something that looks like this?
Or factoring.
Factoring, yes? Can you factor that? Yes, -7 plus 2. What makes this 0? 7. What makes this 0? There's my 2 answers. Yay! You can shove them in and check them. Okay. Oh, easy. If factoring doesn't work, use quadratic form, yes. So I always rule out factoring first. Now, dear God, what would you do with this problem? I'm sorry. You can do it, Jeff. Okay. Would you ever use quadratic formula for this? Never. Never, ever, ever. When? Never. How about no? Because what is quadratic formula's job? What does it solve? Ax squared plus bx plus c equals 0. It solves equations. Is this an equation?
I thought
So
you just
don't.
corrected with the 0.
Yeah, don't. It's so nihilistic. Do you guys know nihilism? Nihilism, nothing matters. Which can be freeing, but it can also be very, So what I mean by that is, don't make everything in the universe equal 0. Isn't that sort of like, no? I get students who do this, and I don't blame you, because a lot of shit we want to make equal 0 if I have an equation. Don't just go, I'm going to make that 0. No, why? You don't know. Okay, maybe. Maybe. Quadratic formula's job is to solve,
Quadratic equations.
yes, equations, yes. Okay.
Not quadratic expressions.
Not quadratic expressions. Kick ass. Kick ass. Alright, now, let's do some new shit. Just to kind of do something very new, and then I'll come back. How would I solve this? Well, let's see. Let's make that a 1. How would I solve... How would I solve that?
Square plus square.
So it's the same idea as before. In fact, solving is almost always using inverse functions, meaning undoing shit. Is my x stuck somewhere? Stuck inside of a radical, correct? So then I want to kill the radical so I can move my x around, because I want to get x by itself, correct? So doesn't it make sense? I want to just keep undoing stuff. So first step I do, like you said, is I square. That kills this. Dear God, don't make that square. Didn't they die?
Yeah.
Didn't the square die?
Yeah.
So let it die. It's not still here, and then you foil it out, and then you have to use quadratic formula. Oh my God. It's gone. It's dead. And on this side I get 9.
Subtract 7, divide by 2.
Subtract 7, divide by 2. Woohoo! Now, going back to your question from earlier. Fundamentally, is there a difference between that problem and how to solve this problem? Don't I square both sides? This dies.
I'll give you the same answer.
Subtract 7, divide by 2, I get 1, yes? But that's wrong, correct? The original problem was this. If I plug a 1 in, does that work? If I plug a 1 in,
No.
does this work? What's 2 plus 7? Square root of 9 is?
3.
So is this true when x is 1? This is a true statement. No. So why, does everybody see that? I need this to make sense. So why did math, when you look at that, you're like, math told me x is 1, Jeff. Math told me. Your math told me, Mr. Math Boy. Yes? But it's not math's fault. We squared. Isn't the first thing we did, we squared? When we squared, do we lose information about if something was negative or positive? Yes. So 1 works in the new equation we made, but it doesn't work in the original. So whenever you solve radical equations, you need to get in the habit of checking your answer. Plug it back into the very original.
So,
Because when we square, we lose information. We might create new answers that don't work in the original. Does that make sense? So it's not math's fault. It's our fault. It's the only way we can solve the dumb thing, but when we do it, we might introduce answers that don't really work. Yes?
how you solve it?
This one has no solution. This, and I can see it from the beginning. Sometimes we're not going to be able to see it, but can the square root of something ever be negative? By definition, the square root is positive because we're picking the positive root. I really want this. It's even worse than complex. There's just no answer to this.
Oh.
There's just no answer.
So I figure like a question like this, you show the work and then after you show the work.
If I gave you this problem and you said no solution because square root can't be negative, tears for you. Beautiful. The more you know, the less you should have to do. But you still have to explain it. If you do the work, check it, and it doesn't work, and you cross through this. That's the right way to do it if you do it that way. Cross through this and say no solution. That's fine also. But you don't have to do the work if you realize, oh, this is a bogus equation from the beginning. I can't make that work. So why would I try? You just say no solutions. Everybody with me? Roughly? Sort of? Screw you, Jeff? Yes?
So anytime the square root of anything equals negative,
You're done.
that's it.
Now, be really careful. I'll show you. Here's another example. Here, let's see if I can make one that works. Would that be nice? That should work. Oh, it doesn't matter, Jeff. Anything is going to work. Sure. Yes, that'll work. Oh, shit. I wanted it to do something different. Hold on. There. Okay. Make the two negative. Can it just stop and say no solution?
No.
Hell no. Why not?
Because you have to subtract from both sides.
My square root is not by itself. I can't see if a square root equals a negative. So what I often say when you have a radical equation, it's like I suddenly start teaching how to be a tyrant of your own country. Because what do? If you're a tyrant in a country, you isolate the radical element and then you kill it. Jeff, what are you doing? I don't know. I don't know. It's just a neat, silly example. Please, dear God, if anybody becomes a tyrant and you go, props to Jeff, no, screw you. Is my radical element by itself? It's got extra shit, correct? So how do I get the radical piece by itself?
I would be able to do subtract from.
Subtract 4, good.
And multiply by -1.
Multiply or divide by -1. So does that say the radical equals a negative number?
No.
Nope. So should it have a solution?
Yeah.
Yes. So now I can do what?
Square both sides.
Square both sides. So when you have a radical equation, you isolate the radical and then you square. Unless it says radical equals negative number, and then you can stop. This one didn't, so we have to keep going. Ha-ha. Yes.
If you had done this starting with like just squaring it instead of doing like minus.
Oh my God. Okay.
minus thing.
Watch this. You ready? Okay. I do not blame you. I don't hold this against you. But I want you to realize what's going to happen. What is the main thing in algebra? If I do something to one side, I have to do it to the other side, correct? So if I square one side, I must square the other side. How do you square this? Write it twice in FOIL, yes? You can't square both parts because exponents are based on multiplication, not addition subtraction, so it won't distribute. You guys with me? So don't just square each piece. That's not allowed. Do you all agree 2 plus 3 is 5? Anybody disagree with that statement? Thank God. If I square each piece, is the statement still true? 4 plus 9, is that equal to 25? There. So I can't square and I can't square root. Those are both powers. Each piece of an addition subtraction problem, because it can't happen that way. Not a bad thought, because you're like, I got to square to kill the square root. Why not just do it at first? Because it makes it so much worse. Okay. Do you guys remember doing anything with radical equations? Anybody doing any of this stuff? No? Okay. Yes. Oh, you remember? Okay. Okay, let me stop. How are we doing so far? If you see an equation that has a radical in it, what's your first step?
Isolate it.
Isolate it. And then you kill it. I like it. Just a little too. Here I go, killing again. Yes?
Or we got secret
For the
first.
others,
Yes.
for the other question, did the negative go away?
Where are we at?
Did I go one before?
Here? This the way we did here? Or where? Sorry.
Oh, we divided it by negative.
Yes.
Oh,
Yes, cool. So now watch this. What if I have this? Okay, let me see if I can make one that works. That'd be so cool. Oh yeah, that'll work. There we go. Is x minus 4, is that positive or negative?
We don't know.
You don't know.
We don't know. What could x be? X could be 800, and then it's positive. X could be negative 1, and then it's negative, correct? We do not know. So it could be positive, so we have to solve it. What do I do? Is my radical isolated?
Yes, it's good.
So when I square, it's not going to make me FOIL or do some weird shit. I could just square right now. Is everybody with me? If I square, it directly attacks the radical. But what am I going to have to do on this side here?
Well,
Yes, dear God, bless you. I always get this. Somebody says this, and then they very quickly get the wrong answer. Don't do that shit. That's not right. I have to FOIL this. That's how I square anything, is I multiply it by itself, correct? So don't lose your middle term. That sucks. So I really hope it makes sense. If I have more than one variable in multiple places, I should expect my problem to be a little bit harder. Yes? Does anyone know where to go from here? I'm pretty sure you do, but hold on. Do you see a power on your, do you see different powers on your x? Well, let's go down that road. If I wanted to use quadratic formula, what does it have to be equal to?
0.
And again, it makes sense because didn't we talk about the whole idea it's got to be equal to 0 so then I know for sure what's going on? Is this equation currently equal to 0? How can I make it happen?
By subtracting it.
Subtract x and
2.
2. Then I get 0 equals whenever you have different powers on your x's, get it equal to 0 and then try to factor. If factoring doesn't work, what do I try? If factoring doesn't work, quadratic formula. Does factoring work here?
Yeah.
Hell yeah. What are the two numbers?
-7, -2.
Kick ass. X minus 7, x minus 2. So what makes this 0?
7.
7. What makes this 0? 2. That's insane. Now, can I just circle those and go about my day?
no.
Done, math boy. No. What do I have to do? What kind of problem was this at the beginning?
Right.
Radical problem. So I'm going to put the beginning over here. If I plug a 7 in, 7 plus 2 is 9, square root of 9 is 3, 7 minus 4 is 3. Equation is true. What do I get when I plug a 2 in? What's 2 plus 2? 4. Square root of 4 is 2. 2 minus 4 is? Negative 2. Is 2 equal to negative 2?
No.
Screw you. Just one answer. Real quick. Do you remember earlier what would it be that would tell you you don't have to do any work, that the answer is no solution? If I have a radical equals negative. Did we know what kind of number this is?
No.
If x is 7, what kind of number is this? Positive. If x is 2, what kind of number is this?
Negative.
Ah! But we squared both sides, which again erases if it was positive or negative, which is why we get more answers than actually exist. So don't hold that against math. We came in and squared shit. We screwed it up. So then we got to check. Does it actually work in the original? Is everybody with me? Because as a student, if I was a student in this class, if I didn't say all this shit, you'd just be, why do I get the wrong answer if I do everything right? You with me? But it's because we couldn't get any answers if we didn't square. But because we square, we open the door to more than the right answers. Okay, maybe. So I'd rather get right and wrong answers than have no way to get an answer. Okay, maybe. Screw you, Jeff. So, very quick word. I was looking at the answers to the survey, so if you haven't filled the survey out, please do, because it really does help me. And in this class, there's such a mix. Some people haven't had any math in years, and some of you guys are fresh out of high school, whatever, with algebra. You with me? Dear God, please, if you don't do math for a while, it leaks out your brain remarkably quickly, which is the only reason why I know math is because I teach it all the time. If I stopped for a few years, it would leak out. Is everybody with me? So there are going to be some people in here who are just good with all of this shit because they've done stuff like it relatively recently. Let them be happy. You with me? Don't gauge where you should be based on what somebody else seems to understand. Does that make sense? It's like me in art class. Painting. What's going on? This guy is like, done with that painting, next, done with that painting. I'm like, oh shit. You guys kind of with me? I can't gauge myself against him. He's been freaking painting since he was 3. Are you kidding me? Doctor tapped on the button. He's like, you need a brush. Okay, maybe. Maybe? Okay. Yeah. So here's the ultimate level of these kind of problems. Let's see what you guys think about this. This will be neat. I gotta make one that works. That'd be nice, Jeff. Oh boy. Hold on. Okay. Okay, that'll work. Okay. Okay, there. Now, what's new about this problem?
There's two.
There's 2 radicals. If I square, now listen, if I square both sides now, do you see how that would be unbelievably disgusting? I need you to see it, because I can't square this and square that. I must square both sides, and then I would FOIL this. Do you want to do that? So if you have 2 radical elements, you isolate one of them and you kill it. And then there's going to be another radical element. So if I have 2 radicals, I should expect to have to square twice. So can you pick a radical and isolate it? What would you do to make one of the radicals by itself?
You subtract.
Subtract the other one. So what do you want to subtract? This one? Okay. So there's no escaping it. Now this side I'll do. So I did half of it, guys. You guys do this side. What do you have to do that side? Oh shit. What do you have to do?
Foil.
You gotta FOIL.
What does FOIL stand for again?
First, outer, inner, last. Which is bullshit. Because it's just repeated distribution. So I say FOIL just to reference a process. But I hate that we made it seem like you need a mnemonic device. It's just repeated distribution. Yeah. So here's what it really means. I have to write this twice. Is that cool? Or not cool, but understood?
Yes.
First, outer, inner, last. I don't need that shit. I just distribute the 4, and I distribute the negative rad x plus 5.
What's it called when you do like a square?
I don't know. I'm sorry.
That's fine.
The grid approach to multiplication?
Yeah, you just like put 4 minus
Yeah,
x.
and you put 4 minus,
4
yeah.
minus x.
If that works better for you, go for it. It's the same math as what I'm about to do. But sometimes the visual just makes people feel better. Yeah,
That's what I always used to do.
I don't blame you. So what's 4 times 4?
16.
Holy shit. What's 4 times negative rad x plus 5?
Negative 4.
So what's 4 times negative rad x plus 5?
Same thing.
Now, what is negative times negative is positive. So what's rad x plus 5 times rad x plus 5? What's half of x plus 5 times half of x plus 5?
X plus 5.
X plus
A whole x plus 5.
Isn't it supposed to be a without the radical?
Sorry?
You said
Oh, I'm sorry. Yeah. So then I get 16 minus 8 rad x plus 5 plus, there shouldn't be there, a whole x plus 5. Because these I could put together. Now, I can feel the excitement in here. This is great. I love it. Okay. No. We got rid of one radical, didn't we? Is there still another radical?
yeah,
What do I do then?
isolated.
Isolate it. Whenever there's a radical in your equation, you isolate it and then kill it. We're all tyrants of our own little countries. So how do I get this by itself? Well, I can, well, first off, 16 plus
You're not
5,
showing it.
oops, sorry, is 21. That's craziness. Now, how do I get the radical x plus 5 by itself?
By adding, by subtracting x.
Subtract 21. And minus x. And then finally,
Divide by negative 8.
divide by negative a. Okay. I know I want to get the radical by itself. So I get all the other shit out of the way. You almost always divide last. So now I'm going to divide by negative 8. And now what can I do? Because you can reevaluate as you do things, you can reevaluate where you are. So this is a really easy problem now, but a lot of students miss out on that fact because you've done so much shit and you have all that shit in your head. None of this matters right now. None of it matters. I just square both sides. Die. So I get what finally? X is 4. Do I circle it and keep going?
No.
No! I have to check it. Does 4 work? What's 4 minus 3?
1.
What's the square root of 1? What's 4 plus 5? Square root of 9. Is 1 plus 3 4? Yeah, so it worked. Check.
How do you come up with these equations?
I picked what x was. Here's how I made this problem. I wrote this, and then I picked x, so it came out to be a nice square rootable number. So I picked 4. Then I made plus 5 because that makes 9. And then I did 1 plus 3 is 4. So I picked the answer to create the problem. Now,
Okay.
in the real world, this shit just happens. We make observations. They're based on square roots. You don't even believe me right now, but there are things that act like a square root. So when I make observations, they naturally model a square root. Then when I want to solve an equation, what do I have to do to make this 20 instead of 10? I set equal to 20, and I do this shit. So in the classroom, I can make an equation by starting with the answer. In the real world, I get an equation from what I observe, and then I have to solve it. Yes?
Can we see the bottom of this problem again?
No. Yes. Sorry. There. I am recording, right? That would suck. Oh, good. Does any of this sound familiar to anybody? And if it doesn't make any sense. Does it make any sense? Any sense? Okay. Like some of you guys are like, I'll say yes now, just so you won't look at me anymore. Okay. Okay. The big thing to me is as you're solving a problem, you do one thing, then you reevaluate. A lot of people think you somehow have to keep this in your head. That's insane. The minute I do something, this shit is dead. It's gone. It's when I get to the end, I go, oh, I gotta go back to the beginning and make sure it's good. In the middle, the minute I do something, what was there is gone. It's dead. In fact, I've told people to take a piece of paper and cover their old shit because they just couldn't let go of it. Thank God we don't have to keep it all in our heads. Okay. Yes. Good.
Could you give me another example of the two radicals? 'Cause
I mean, I could.
Please.
Yeah, sure. Make sure that works. Yeah, it does. This one's a little more straightforward because what do I obviously want to do? And let's see if it is obvious. What's the easiest thing to make a radical by itself? Just add this guy, yes.
Yeah.
Whenever something's negative, if it doesn't matter which one I move, I'm going to move the negative one because that would add it to both sides. I don't have a bunch of negatives flying all over the place, right? So if I add this to both sides, and then I basically just square both sides. All the same stuff happens. Do you guys see that? Square both sides. I have to FOIL this side. I get my radical by itself, just like we did last time. So once you do one of these, you do a couple of these, you're like, oh, there's a tempo to this. There's a pattern to this. He basically just keeps doing the same thing. By the way, I am talking a lot today. Tomorrow I've got a worksheet that goes over all of these that you guys are going to work on together.
Yeah.
So today is just me laying out a lot of methods. Tomorrow you're going to get to put hands on and figure out those methods. And before I forget, let's talk about, before I forget, I think our first quiz, I'm going to make it on sections 1.5 and 2.4, and we're going to have it this Wednesday.
Yay!
And then quiz 2, I'm going to make that 2.5, 2.6, 2.7, and that's going to happen next. Do you want it? Let's see. What's going to make more sense to me? Oh, yeah, next Monday. So we got the first quiz and the next quiz right there. Yes, sir. Do it again?
It's President's Day.
Oh, I'm sorry. Next Tuesday. That would be like a plus evil class if I make you come here on a holiday. You know, just drive around the gate that they put down. Just drive around and get up in here.
Just hop the gate.
Break into the
Yeah,
building.
it's
Come
full
on.
exercise.
Come on. Show me you really want this. Good. No, let's do it Tuesday. Yeah. All right, so last thing for today. What does this mean? How do you read that?
The absolute value of negative
Yeah.
4.
What is absolute value of -4?
4.
Why?
Because it's how far it is from 0.
Why?
Because that's how
I
far it is.
love that. Yes.
It's the distance between -4 and 0.
Kicking ass. So the absolute value is the idea of distance. Not to get too much into this, but that's one. If I go to 2 dimensions, absolute value still means the same thing. It means the length of the line segment from one point to another point. So it's the distance between two things. So if it just says absolute value -4, that means how far away is -4 from 0? And you wouldn't say it's -4 away. It's like if you're 4 feet away from me, even if I turn around, you're still 4 feet away. I wouldn't say you're -4 feet from me, because then you'd be inside me. Like, Quaid, rah. You'd be, rah. No? Okay. That would be weird. So this is 4, because -4 is 4 away from 0. What's this? 4. Because 4 is 4 away from 0. Oh my God. So the short way to say what an absolute value does is it makes things positive. If they're already positive, it does nothing, it just leaves it. So let me trip you guys up. What is this?
X.
Can't be x. It can't be. Because what could x be? X could be negative, correct? What else could x be?
Positive.
Positive.
Positive plus or minus.
Where's 0? It's a definitive thing. So if x is positive, what does this equal? If x is already positive, will the absolute value do something?
No.
No. So it leaves it alone, correct? Like this. Leaves it alone. What if x is negative? Well, this is also if it's equal to 0. If it's 0, then it leaves it alone, correct? Because 0 is 0 away from itself. If x is negative, what does it do? Huh? No. If absolute value -4, did it leave it -4? No, it changed its sign, correct? What algebraically do I do to change the sign of something?
Positive X.
No.
You multiply.
We could, as a human, I could just not write the negative and I made it positive. But what do I do to something computationally to change its sign?
You multiply.
Multiply by negative. So this always trips people up. You ready? If x itself is negative, the absolute value of x is -x. Why does that make sense? If x is negative, what's negative times negative? Hey. And isn't that what an absolute value is supposed to do? Let's test this. If x is negative, so absolute value of x is -x if x is less than 0. If x is -4, it would be -4, which is 4, which is what it is, correct? Okay, maybe. Okay, yes.
If your equation was absolute value of x equals x, and that was,
No, that's a different question. That's an equation.
yeah.
And in that case, the answer would be all x is greater than 0.
Okay.
Yeah. So, oh my gosh. Watch this. What would you take the absolute value of to get 3?
It could be 3 or negative 3.
-3 or +3. Do you see how there are two cases? The inside is 3 or the inside is -3. So what about this? What are my two cases? Isn't x minus 3 a number?
Yeah.
What could x minus 3 be so the absolute value of it is 5? No, you're thinking about x. What could x minus 3 be? The absolute value of what is 5?
X minus 3.
5. So either the inside is 5 or the inside is
Negative 5.
-5. So you're not trying to do everything in your head. Whatever's inside could either be 5 or whatever's inside could be -5. So then you get 8 or -2. All right, that's plenty. I got to get to my workshop anyway. All right. Do you have any questions? Let me know real quick.
Is the workshop part of the system?
It's in the Sissel,
Okay.
but you don't have to be registered for it. You can just come.